let's just recap what you should be able to do. Explain how sound waves are caused. Know the relationship between frequency and the period of a wave. Use the wave equation to solve problems related to sound. Solve problems related to echoes and echolocation. Relate the pitch of a sound to frequency. And finally, relate the loudness of a sound to the amplitude of the wave. Welcome now to the actual part of the lesson. One of my favorite pastimes is to read. So I'm going to read to you a small section from Agatha Christie's crime novel, A Story About Miss Marple. It was a dark night, and Miss Marple could hear nothing move. Then suddenly there was a shrill scream of a woman, and a loud shout of a man, and then a gunshot. It took about 1.5 seconds for the echo to bounce off the cliffs. Miss Marple wondered how far away this crime had happened. Okay, grade 10, so let's go through some important facts that might help Miss Marple solve this crime. Okay, so firstly you need to remember that sound is a longitudinal wave. Okay, so it travels through air and mediums by compressing and stretching out the particles because of vibrations. So B is showing a longitudinal wave. C is just showing the where the compressions are happening. That's where the crest is, where the particles are stretched out, that is where a trough is. So, as I've just said, the areas where the air particles are stretched out or less dense are called refractions, and the area where the air particles are compressed and close together and more dense are called the compressions. So as you saw in the PhET simulation, the particles move in and out, and you have areas of more dense air particles where they're close together and less dense. Okay, let's look at amplitude and loudness. Okay, it said the woman screamed and the man shouted. Now a scream is much, much louder than a shout. So what is the difference between the woman's scream and the man's shout in terms of loudness? Okay, there is a loud sound. Okay, so for example, the woman's scream. There is a softer sound, for example, the man's shout. What do you notice about those two waves? Okay, yes. Loud sound has a larger amplitude than a soft sound. Now, the woman also gave a shrill scream and the man had a gruff voice. Okay, so what's the difference between pitch and frequency? There we have a cello and a violin. Cello is a lower pitched sound and a violin is a much higher pitched sound. Those two sounds are the same loudness. And as you can see there, the lower pitched sound has a lower frequency, where the higher pitched sound has a much higher frequency. Now, what does that actually mean? Okay, for a low frequency, the period is longer, the waves are further apart, the wavelength is longer. Whereas for a high-pitched sound, the period is much shorter and the wavelength is also shorter. So low wavelength, high frequency. Man's gruff voice, low frequency, long wavelength. Okay, so in terms of calculations, okay, you need to know how to use the the wave equation, which is the speed is equal to the frequency times the wavelength. Now you have to read the problems carefully. If you are given the frequency and the wavelength, you will use this equation. If you are given the period, remember you have to convert the period to the frequency, and the period is equal to 1 over f. Please remember that. Okay, now, sound travels at different speeds in different media, but it travels at a constant speed in that media. So you can see there in air, speed travels at about 331 meters per second. In water, it travels at 1,496 meters per second. In something like copper, it's 6,420 meters per second. So the speed of the sound is related to the density of the substance. The denser the substance is, that means the particles are closer together and sound will travel faster, because sound needs to travel through a medium that relies on vibrating particles. Whereas in air, because it's a gas, the particles are further apart, so it can't travel as fast. So just remember that. From the source, the sound needs to travel through a medium that requires the particles to be compressed and stretched out. Compressed and stretched out, just like you saw in the PhET simulation. Okay, now Miss Marple said that it took 1.5 seconds for her to hear the sound. So she could actually calculate the distance if you hear the sound. That's how you can work out how far, for example, lightning is, by listening for the thunder. Here you will need to use the average speed formula. Average speed is equal to total distance over time. Now when it comes to something like echoes or echolocation, you've got to remember that the sender will send out a sound. It travels at a constant speed to an object. It is reflected off the object. Remember, sound is a wave, and waves can be reflected, and then it comes back to the sender. Based on the time, you can work out how far the object is. So in terms of time, the sound has to travel to the object. Let's say that takes 2 seconds. It bounces off the object and travels back, and that takes 2 seconds. So as the listener, you will know that it took 4 seconds for the sound to come back to you. You divide that by 2, you will know how far the object is away from you. And that's very important when you're solving problems involving echoes and echolocation. Okay, so that is the information that you need to be able to solve the problems that you will be given in the tutorial. So I hope that you found this informative, and it's going to help you with your problem solving. Thanks very much. Grade 10s, that's the end of this blended learning lesson on sound and problem solving. At the end of the video, you will find the tutorial questions. Remember, the aim of the tutorial is for you to get together with a couple of your friends, sit together and work through and solve the problems. Then look out for the tutorial video on sound and problem solving. Here are the problems for you to solve, grade 10s. So these are the tutorial questions promised at the end of the lesson earlier on. Remember, for tutorials, if you would like to work with somebody to help solve these problems with you, you are more than welcome to get a friend to help you and to work with you. So there are 5 problems. Problem 1 relates to dolphins emitting sound to use for navigation. Problem 2 is a problem related to sound waves associated with human speech. Problem 3 relates to bats and the use of echolocation. Problem 4 relates to finding the distance from hearing the sound of an echo. Problem 5 is a little bit more challenging. It also deals with an echo. However, the object is actually moving when it emits the sound. So good luck, and remember, don't give up with problems. Always try and find solutions to the problems that you are given. Don't just leave them blank. Try them. Pause the video now. Welcome now to the post-lesson activities after the session. This is now the first post-lesson activity. As you can see, it is a video tutorial, and I'd suggest you open a YouTube or a separate tab now so that you can access YouTube. The video is from Beyond Learning, and it is a revision of waves, both longitudinal, transverse, and what you have learnt in sound. There is the link for you to click on.
Transmission of sound.
To consolidate your learning, I'd like you to do the first post-lesson video tutorial. It is basically a summary of some of the important things we've covered, and as you listen to the video, take notes. Pause the video now. Okay, grade 10s. This is now the last lesson for this activity. Post-lesson activity 2 is from the textbook Everything Science by Siyavula, and it is for you to practice some problem solving. So, firstly, I would like you to do exercise 10.1, where you will get some practice drawing waves with different pitches and different volumes. Then, exercise 10.2 is the end of chapter exercise, and I would like you to do problems 7 to 24. Remember, try and solve all the problems, because practice makes perfect. Pause the video now. And grade 10s, that's the end of this lesson on sound and problem solving. I hope you enjoyed the lesson, and I hope that you learned a lot. So, until next time, see you soon.